Welcome to myprojectbazaar.com. Harmony, Dynamic Heterogeneity-Aware Resource Provisions in the Cloud. Abstract. Harmony, a heterogeneity-aware resource management system for dynamic capacity provisioning in cloud computing environments. A means a clustering algorithm to divide the workload into distinct task classes with similar characteristics in terms of resource and performance requirements. The DCP is an optimization problem that considers machine and workload heterogeneity. It is more flexible and can provide a highly efficient solution for DCP for arbitrary workload composition. The heterogeneous characteristics will lead to both suboptimal energy savings and long scheduling delays due to incompatibility between workload requirements and the resource offered by the provisioned machines. Proposed system. The proposed system performs both workload and machine heterogeneity found in one of the Google production compute clusters. Our goal is to ensure high accuracy of the characterization while supporting efficient task classification at runtime. Achieving a high accuracy in characterization can be realized by properly controlling the number of task classes that dynamically adjusts the number of machines between energy saving and the scheduling delay. Advantages: energy saving and scheduling delay by maintaining on 80% utilization of the bottleneck resource, increasing diversity, stricter access control, security service, reduce the error in relabeling process. Existing system. The existing system performs, which is the heterogeneity of both workloads and physical machines. The existing systems are providing to perform these processes, understanding workload and machine characteristics in production clouds, dynamic capacity provisioning for balancing the trade-off between energy saving and application performance objectives. A heterogeneity-aware DCP controller is designed to adjust the number of active machines based on the current machine availability and workload composition. Disadvantages: DCP as an optimization problem that considers machine and workload heterogeneity as well as runtime electricity prices, dynamically adjusting the number of active machines and increasing the energy consumption, delaying energy saving and scheduling at a runtime. Data flow. First, create data center. The user goes to create the number of data centers and it moves to create brokers. The user again create the number of brokers. The brokers and the data centers gets the bandwidth values, number of data centers and the brokers. Then get virtual machines. Again the users create the number of virtual machines. And job allocations. We are going to allocate the number of jobs to do in this process. Then load analysis. What are the processes we are did? The load to be we are going to calculating the process. Then again it moves to get user priority. First we are going to calculating the priority of the users and they get task values. The normal task values we are going to get normal task. Then the normal task values having the bandwidth values, VM and the ID and number of brokers, and finally analyze the values and we are going to get the graph using the values. From here I am going to run the project Harmony, Dynamic Heterogeneity-Aware Resource Provisioning in the Cloud. Next I am clicking the enter button. It moves to next frame. data center creation. So here I'm going to create the number of data sets, data centers. I'm clicking to create data center. Here I'm clicking enter the number of data centers. I'm clicking OK button. It moves to data centers. And here I'm going to create the number of data centers. Then in 5 data centers I'm going to get the number of machines, host ID, and number of PEs, RAM, and bandwidths are created. Then I'm clicking next button. Then here I'm going to create the brokers. Enter the number of brokers of 5. Then I'm 5 created successfully. Here I'm going to get. Then I'm clicking next button. It moves to next frame. Here I'm going to create virtual machines. Get the number of virtual machines. Here three number of virtual machines. Here I'm going to create it. Then here the number of 3 virtual machines here going to create it, 0, 1, and 2. Then this is on virtual machine ID. Here broker ID, nodes, RAM, and bandwidths are calculated. Then I'm clicking next button. Here I'm going to get the job provisioning. Here number of cloudlets. Here I'm giving 2 cloudlets. 2 jobs created successfully. The jobs are created. Jobs submitted to respective brokers successfully. Then here cloud ID, cloudlet ID, broker ID, length, file size, and output size are created in job. I'm clicking next button. It has an analyzer, load analysis. Load calculated successfully. Here virtual machine ID, bandwidth, latency, speed, cloudlet length, and execution times are calculated here. Then here 10, 11 to 0, 9, 1, 10, like that. Here I'm going to calculating the load analysis. And I'm clicking next button. Here I'm getting the get packets, number of packets. Here I'm getting the packets of the users. Here these are the packets of the data. So packets of the data and the NOP values here I'm getting. These are the NOP values. The NOP values is a number of using the number of packets. Then here I'm getting the interaction time and clicking next button. It moves to next process. Here I'm getting the time slots and then getting weighted values of the users. Weighted values. Then I'm clicking priority. It moves to next frame. Then here I'm getting the normal task. Normal task is an performing to the number of users and the cloudlets. The bandwidth values. Here successfully get normal kind job data. The values are performing in this process. Cloud ID, bandwidth, latency, speed, and cloud load, length, and cloud load. These are performing with the use of job allocations. Then I'm clicking next button. It moves to next frame. Here I'm resource collection. Here I'm going to collect the data, resource collected, and here I'm viewing the data. The data is to be displayed here. Cloud ID, virtual machines, and bandwidth, speed, cloudlets, and execution times to be displayed here. And finally I'm getting the graph, analysis, modeling, and simulations of workload with speed and percentage and between the existing and proposed system. Thank you.